Hello, everybody. This track streaming just started. While the previous session ends, I want to briefly remind you that you could ask question in the Q&A session or to chat in the session chat here probably in your right hand side. And now I have the pleasure to introduce my dear colleague Vassil. Momtchev, who is CTO of Ontotext, and he will discuss with you and will present his vision about our technology ecosystem. Vassil, please, the stage is yours.
Thank you, Milan. And I'll ask you if you have any questions, please send them in the Q&A session of this talk. Because if you send them to the lobby, it will take some time to answer it. So the intended purpose is to have these questions and in order to have some time to answer it. So this talk is going to update you on the latest technology trends and what is going to happen with the knowledge graphs. But before really to dig into the future, we have really, as like the previous speakers, I have really to go back a little bit in the history in order to fully understand why we have this emerging technology and is it really new as all the previous speakers actually covered it already. So knowledge graphs is an evolution or a revolution, and this will be first part of the demo of the presentation where I'm going to cover how the enterprise market has changed and why we have this demand now. The next one will be the technology ecosystem, what it takes to really to build a knowledge graph and how you can prove successful projects. And the last part is going to be a quick summary of the latest technology trends and updates you can expect from the market. Okay, so in order to answer the future, we have to look in the past. And this story started maybe 15 years ago, at the same time as Francois was referencing it. This is when I met Naso, Atanas for the first time, and he onboarded me with this picture, which was really 15 years ago. It's a knowledge graph, or pardon, it's a semantic network. That was the name back in this time. And it was depicting the idea how you can understand text and build a semantic network which represent all the entities. Uh, Actually, it's really, you can see the picture is a bit bright because this was really taken many years ago. But this picture is still actual, and many people actually understand the knowledge graphs in the same way. And if we have to trace back the history of this picture, I have a slightly different history than George. And basically, the idea of semantic networks was created by one botanist. It was Richard Reiner back in 956. 56. There are more than 50 years ago when he created this idea that there will be a semantic network in computer linguistics and it will be used for machine translation and knowledge representation. Probably this idea was too innovative in that time, and I was never able to find even a picture of this person, which is quite pity because he had fantastic idea. Anyway, this was really how everything started, and actually, Atanas had their first successful project with BBC, which really realized this maybe 10 years ago. And to our best knowledge, this was probably the first public system which was describing how organization can bring all their reference and master data in a knowledge graph. They can formalize all the relationships and operate this type of system for the BBC World Cup. Actually, this is a production system which operates a knowledge graph since 10 years, and it's still a live production system, which is the backbone of the knowledge management in BBC. And back in that time, it was guaranteed, at least this is what we were thinking, that this will be an easy replicatable success with other companies. But to be honest, this was not really the case because once we faced the other enterprises which were not investing in any innovative technology, we saw the classical thinking of there are two types of systems. One are the operational systems, and the other data warehouses, which were born in order to solve the problems of the operational systems. And basically, the traditional operating systems, they were running how the business works and operate. What should I do in order to run my business? And the data warehouses, how to manage my business, which was another aspect. And typically, the people understood the concept of the knowledge graphs. They were big fans, but they were asking, "Oh, you're making something as an analytical system for knowledge graphs?" No, thank you. We have a really hard time to deal with our ETLs. It's a fantastically difficult process, even without new technology. So, thank you. We'll continue to push this in this way. Few years later, there was some demand and a better proliferation of the databases, and we saw the rise of the graph databases. And this was really the place where the big split between the RDF databases and the property graph databases started back in this time. And actually, if you see this diagram, you see that there are two scales there. One is the model richness and the other model scale. And the graph databases were born in order to help overcome some of the limitations of the traditional operating systems. And at the same time, there were other type of systems like data lakes, which were really for optimized for big data, because back in the 2014, when this trend started with big data, everybody was thinking that uh, a bigger scale of data is better. But actually, it turned out that this was really a very marginal success of these type of data lakes. Although they were able to collect all the company data, there was little of use of this data because it was difficult to harmonize the data. And although it scaled very well, these type of systems proved a little business value. And every time you needed to interpret the data, you had more or less the same type of challenges like the data warehouses, because they were really type of a replica of the traditional operating systems. And this was really the rise of the data hub, another type of systems, which started to talk that it's not only about the scale of the data, it's also about the size of the model and how many entities you can represent. And the data hub were actually the first systems which really say that the value, once you start to get a more scalable, a bigger model with more entities, types, and properties between them, you need to organize them in some sort of a semantic way. And this was really the size of the models which makes the difference. And this was nothing more than databases which were using XML or XSD schemas in order to do something as a semantic markup of the data. At that landscape, actually, it was the market analyst recently who found out that there are some extreme limitations in this technology landscape. The graph databases, they are very good databases, but they relatively, especially in the property graph model, work on a smaller scale problem. Okay, George gave some good examples about Google Map and things like this, but what we are going to find out that the typical property graph databases, they deal with a fairly simple model. The typical use cases are fraud detection. You have transactions, a fairly limited amount of graph links, and a fairly limited number of entity types which are described. And probably there are good application models in order to design them, but they were not able to scale with a lot of variety of data, which was really now present in modern enterprises. The data warehouse, more or less, over there were some operational improvements stayed more or less there, and it was still a pain how to develop them. Every project was a big one, new initiative where you had to start everything from the beginning. And the data hub, they worked only for simple models, which were mostly adopted by the publishers and the people who had relatively simple models. And that's why when the market analysts saw the trend of enterprise knowledge graphs, and you are going to see that, okay, it's a big bubble there. Why this is so big is because the knowledge graphs can be used in various use cases. In the most extreme, whether the scale is small, the people use them in some sort of a special form of inventory type of system of data catalogs, what is really there, how to manage my metadata. And in some extreme ways, there were really some extreme other boundary was really how to make this as a big scale of data. And in the age where the decentralization become an important topic, because in the software architecture there were microservices, and the idea was how you're going to organize a big team in order to split the task into multiple smaller teams which are independent. Also, the uptake of the knowledge graphs was very appealing because you could split the complexity of the model to multiple data groups. This is some people what they call data mesh or domain driven design in order to make the system interoperable. And that's the main reason why we can say that the enterprise knowledge graphs can scale in size and then the decentralization, because the link data cloud is something like this. It's a highly decentralized system where the people reference their data. So this is really the big promise and the void where the enterprise knowledge graphs were deemed to succeed. And yeah, this is the trend. So whether this is an evolution or revolution, I would say this was really evolution of multiple factors. The person who invented the idea of semantic network probably was not aware what will be the impact of his research, the person doing some botanic research. But by the evolution of the digital transformation and how many of the businesses started to transform their business into digital, digital, sorry, operation, it became really the need to how to better manage your data. And this was really the case where the information really, for the first time, became as a product. It's really something of first-class citizen. And the people wanted, of course, to have this in a data-driven design, where to be agnostic about the vendor and what is the actual API of the concrete implementation of the system. They wanted to manage their data as a product. And want the other things which were important in one big organization, the people want their data to be findable and to be able easily accessible. And if you want to find out, there will be a fantastic talk later by Martin Romakier, who is going to talk about fair data and the principles how one pharmaceutical company is doing data strategy based in their domain. Because it's known that it's much cheaper to find the existing information than to redo any experiment once again, which can be a very expensive task. So at the end, this is really the shift and the revolution with the knowledge graphs, that the people started to become, the information became a first class citizen, and the people were stimulated to do different domains in order to manage their information in a better way than it was existed. And the other change was that the knowledge graphs were seen no longer as purely analytical and like the data warehouse or the logical data warehouses. This was really operational and analytical use cases where, by standardizing how you manage metadata or the general master data, it was easier to to improve the quality of the operating system by saying, okay, if I log in, I have to select the company, and the company is not just a string but an ID from our knowledge graph. And also it enabled a really cooperation and much more complex models between different organizations which were sharing now data. Okay, and the next part is really of this presentation is the technology ecosystem and how you can actually build knowledge graphs. This is a fairly complex slide. It was actually presented by Atanas, but the slide was a response from the market analysts. Once there is a trend and technology boom, the market analysts, they go always to the technology vendors and ask us, why knowledge graphs? Could you give us what are the differentiators and what it matters for the different type of systems? And this was actually the best still representation of what are the knowledge graphs and how they can be mapped to the horizontal technology areas pushed by the different market analysts. So knowledge graphs are a very fundamental system in the same way as the data warehouses, data lakes, data hubs, and all these type of information systems. And they can be used in many different type of application areas. What is specific is that the differentiators of the knowledge graphs, I will not mention them once again, about the distributed IDs and how you can decentralize the model and so on. But they are really purely technical and technological. In order to prove some business KPIs, you have to go to the knowledge management and go to some specific areas where to go in some concrete KPIs for the business. For instance, in the business process management and automation, the connected inventory is what will give interoperability between the many different devices. This is the idea with the digital twins is really something which makes a big difference. And you are going to see some of our partners who are going to make some different horizontal presentations describing how the knowledge graphs can be implemented in all these type of areas. And also you're going to see some vertical applications, how you really solve this in a specific vertical area. So I will not go deep into the details, but the other question was, we as a business were asking ourselves, okay, there is so big demand on some capabilities, build a knowledge graph, how we should organize our portfolio and make everything doable. And we find out that building a knowledge graph is a too, how to say, too diverse type of an activity because all these different applications. So we divided this type of areas like building, storage and indexing knowledge graph, operations, how you really operate the knowledge graph and maintain it, and exploration and analytics. And this is our understanding how Ontotext decided to build partnership with many different organizations because at the end the ultimate client they were willing working and tested solutions which can just pack all this software and run it. I will not go into the detail how the information is split, but in this knowledge graph forum, you're going to see some of the best technology vendors around knowledge graphs. So, what are the technology trends and updates? This last part is going to reflect the insights we gained from the last years and this increased demand. And I would say that specifically we talk about knowledge graphs here, and I want to differentiate from the graph databases because the graph databases, although somebody will say they are now very scalable graph databases which have sharding and distributed models, the graph databases are mostly focused on a very narrow model domain. Typically, they have a couple of relationship and a couple of entity types. And the knowledge graph is really how to bring all your information as a product, connect it, and enable new type of use cases, which is a quite different story in our eyes. So, what are the technology trends? Decentralization, and the people started to think that it's no longer a central government which can cope with the agility of the business. And of course, the knowledge graph have multiple implementations. It's no longer a single repository which can deal a central system which can deal with all the agility. So in addition to the native repositories, which of course are optimized like the graph databases for advanced queries, and they are optimized really for very rich models, the other emerging things came out like schema reasoning and validation. And the validation and the data quality actually is not a less important topic, how you validate the data and how you ensure consistency of your information. So there is a new demand, which something which didn't exist in the original semantic technology, how you do data constraints, like in a classical database with the RDF shapes. So obviously all the RDF repositories somehow push this technology in order to do a strict validation like the databases. The second big thing was the virtual repositories. Actually, it was covered several times that if you have a nice design system, it makes probably not much sense to go through painful ETL process, which all the data warehouses suffer. And actually, they are quite efficient now, converters from Sparkle to SQL, where you can describe your knowledge graph schema and map it to a SQL engine. Actually, this will push some of the complexity down to the relational database. And the last but not least, once you have this decentralization, the people will start asking, how I do graph exploration navigation. I know that there is such data. I know that there are different decentralized repositories. Is there any way how to approach this? Obviously, this is not a simple question. Once you break the locality of the data, not all the operations will be possible. But still, GraphDB offers these type of federated repositories where you can connect it over multiple Sparkle endpoints and to access them as a single repository. Typically, this will be based on predicate statistics, and there will be some basic query optimization depending on the data distribution. And of course, there will be also the requirement for efficient federation. Once you start many repositories, how I can efficiently access the data in a more efficient way. So the next big trend is really the upstream and downstream replication with Kafka. If you remember on this technology map, the data lakes really based a very solid infrastructure, how the different systems can exchange data. And Kafka, mostly in the big enterprises, is implemented as a data bus layer, where the different systems there should be no integration between every two systems, what goes with the classical data warehouses, but there will be a bus where all the changes of all the systems will be collected over Kafka messages, and then there will be a connection between the providers and the consumers, and it will be one-to-one based on data formats. So since this infrastructure exists in many of the big enterprises, many of the people wanted, okay, I want to connect my knowledge graph as a provider or consumer. And in the last year, this was really the trend and the new features which were released in order to support how GraphDB can be a provider, but also a consumer of this data. And there will be updates from the Kafka messages. There will be a special topic and presentation on Kafka starting in 1 hour exactly from now on, which is going to dig into more details, how you can really design no-ETL solutions with Kafka and graph data and knowledge graph databases. So the last thing, the next thing is once you transform the data, there is a requirement for automatic entity linking. What is entity linking? Entity linking is how you convert strings to things. And this is one of the big limitations of most of the other databases, is that they cannot differentiate some ambiguous entities. For instance, London, there are many cities around the world with the same name, although the people mostly reference single city, but in enterprise systems, you have a much bigger ambiguity. So what is the entity linking? That is the task to take the string American Samoa, which is a US territory, and to conform it to an ID in the knowledge graph. And yes, there will be at least two presentations, one product and also one presentation by Ontotext explaining how to do this entity linking, because this is a critical task, how to make your data semantic and how to convert the strings to things. And in this case, you're going to use the human labels. Obviously, this is the starting point to disambiguate the entities, but also you are going to use the type and the semantic context. And you see that even in simple examples, there might be some ambiguity. If you take the American Samoa, depending on the type you are asking, you can disambiguate this as US territory in the Pacific, which has in Wikidata one entity, or depending if you say this is a country, it will be a sovereign state, which is the North United States, which is the owner of this territory. So in order to have this semantic context, you need some tooling which is going to guide you through this process. And on the right side, you have the high-level architecture on this. Stay tuned. There will be a couple of talks talking how to do automatic entity linking and data reconciliation. And really the important thing is how to make this WIFE scalable on large amounts of data. The next one is really, you remember the story, how everything started with the text analysis and the original idea of semantic networks. And text analysis is still one of the dominant use cases in knowledge graphs. And the two main use cases is how I do a better text analysis with knowledge graphs when I don't have enough machine learning training resources. And keep in mind that in the academia, there are very good available resources. But if you go to commercial setup, the training resources are really very limited. So in many cases, in order to do text analytics, you have to combine a rule and machine learning approach. So this is the first case. And the second use case is obviously the original idea, how I can build a knowledge graph by processing unstructured documents. We all know that this is possible in some constrained domains, and it's a much more difficult and still impossible task for a general general artificial intelligence model. So the basic demand now is no longer how to do text analytics, but how to integrate multiple text mining plugins, because currently there are over 300 public text mining APIs, which are going to perform some sort of a classification, entity linking detection, or name entity recognition, or some other type of classification like sentiment analysis or whatever could be else. So the basic idea is how you can make all these type of text mining APIs interoperable. And actually this approach is how to make their metadata, the annotation metadata, represented as RDF and use it as a way how to generate higher level type of text mining pipelines. So there will be also a special talk how Ontotext is doing text analytical solutions later in this conference. So the next one is really knowledge graph as a product. And this is the next trend which comes. Probably many of you are familiar with data as a product, where you give an information product to the organization. But so the knowledge graph as a product has the same type of features. Once you design your type of reference model or master model or whatever type of data you have in your enterprise knowledge graph, there should be SLA in order to make this as a business critical operation. And more clients are able to push their type of systems from the lab, where they have experiments and really some sort of small scale models, to really big production systems, where if these systems go down, you start to lose money. So the next trend about the knowledge graphs is how to ensure a quality, and this is done by schema checks, provenance, and lineage, and all these type of toolings, which the RDF model is really perfect model in order to track this. And this is quite difficult in many of the other type of technologies like data warehouses, the classical graph databases. If you don't have a schema definition and you don't have clear semantics over the model, or the data lakes, which are just dumps of data. So the next one is really availability. This is a business critical operation system, and actually you need uptime and response time. How do you ensure this? How you make clusters of these knowledge graphs in order to be reliable and robust operation? And last but not least, nobody wants to lose their data. So the disaster recovery, multiple data centers, automatic failover, these are all topics which are becoming much more critical for the success of this technology. So if you are looking for a good knowledge graph product, be aware that you need to find a solution which solves all these problems. And the next one is really how you consume the knowledge graphs. And this is a very common question because the people are asking, actually, what is a knowledge graph and how I can interact with it? We found in our experience that there is no single way how to interact with the knowledge graphs. And we classify the personas in every organization into three main type of groups: the direct people who interact with the knowledge graph. One are the business analysts. These are the people who knows very well statistics and the data. And the distinctive feature is that they are experts in some statistical tools. They'll never forget their tools. They always want to use it. So every knowledge graph, even it sounds a bit, how to say, backwards to think, they need to expose the same JDBC endpoints and the same type of resources which to connect to it. So typically there should be a way how to map the graph to a table in order to business analysts consume this data and make the reporting. Obviously, this should be live. There should be no dumps. But to make a copy of the model, the people will never leave their favorite tool. The next type of people who is really probably the biggest growing community of the data engineers and scientists, it's a really a modern trend now in big organizations, is the people who wants to understand the model and to get a deep understanding about the model and the semantics. And last but not least, the software engineers who wants to really consume this from an API. GraphQL was mentioned several times, but GraphQL is not a database query language per se. It's really an API query language, and typically you need an easy way how to map the database models to GraphQL. Last, I'm going to mention about the roadmap and what's coming in the next year and months. GraphDB 10 is coming in 2020. It's really optimized to, there will be a massive redesign of the cluster in order to improve the DevOps experience and how the people operate highly available systems. Obviously, there are other minor features. Few other things to mention is really the drop of Java 8 support. Sorry guys, if you have still use Java 8, you need to migrate to Java 11. It was really for many years now the default installation. And obviously, we're going to launch a new text analytics products, which are going to really solve these type of challenges, how you use knowledge graphs to generate text analytics, and the other is how you populate them. And obviously, the developer experience is quite important. So we are going to continue to invest in GraphQL infrastructure and how you can do better automatic linking and reconciliation. So let's go and see what are the questions in the panel while I was presenting.
I summarized those. So there was a quick one. Is the Kafka connector available in GraphDB 3?
No. So the Kafka connector is available with other replication systems, so only in the GraphDB Enterprise Edition. But the good thing is that you can always download an evaluation license of GraphDB Enterprise and test it and decide if it's going to fit your needs.
Okay. Well, then I probably provided a misleading answer in the chat. So yeah, you got to go for the standard or enterprise version for it. Then there was a question from Oliver Roussel about the confidence, how we measure the confidence of entity linking. So do we have some means to figure out precision recall? Yep.
Yes, there are some wonderful open test corpuses to measure this, and I'm sure that if you go to one of the two demos discussing entity linking, they will cover this topic. But yes, there are some standard benchmarks how you can measure not only the accuracy, not only the performance of the matching, but also the accuracy in terms of false positive, false negatives, and so on.
There was some discussion on data votes. versus knowledge graphs. Data vault is a more traditional concept in data management. That's about having a system which gives you proper history of everything that happened with one data set. So a lot of provenance on how the data was looking at different points in time. And my comment was, you can provide yours. My comment was that you can do this in a knowledge graph system, but knowledge graph system is much more about providing unified views. And yes, there could be multiple versions of truth due to one and the same piece of information potentially coming from different systems. Which is also the case with data vault, that you can have multiple versions of truth. But yeah, that's still, at least from what I see, data vault and archiving and history is not the most typical application for a knowledge graph.
Absolutely, and the knowledge graphs can model also temporal information. This is something, there are many use cases which actually need to know what was the historic view over this data. But per se, yes, the knowledge graphs are really like a reference models where you want to find the current internal ideas of the projects, who are the people working in the company, and obviously, yes, if you decide that you need the temporal aspect, you're going to have two properties, start and end date, where this person was an employee. So the knowledge graphs really the biggest added value, I would say. They give you a much bigger scale of the information management by dividing and decentralizing how you can make different domains which are connected by using the web principles. And also the size is not limited. So in many aspects, I would say that this is really the target, the ultimate paradigm, and the people can use this only for metadata or for all their master data. But the general challenge in these type of systems is how you decentralize the model in order to preserve the agility and ensure the central governance in order not everything to mess up.
Yeah, well, Nikolai, our colleague Nikolai Krstev, provided a reference in the chat for this session about the data history and the data versioning. So GraphDB has a lot of provisions for tracking of changes and tracing changes by users and stuff like that in the database. But yeah, that's still not a data vault typical story. It's more tracking changes and they're helping the governance of the data. So these were pretty much the questions. Vassil, you did some wonderful references to the following presentations. I'll take the opportunity to just mention again that the next session goes in 2 tracks. We have the business track that is dedicated to life sciences and publishing. And we have another track, a technical track on building and managing graphs. So check the agenda, enjoy the break. During the break, you can visit the booths and you can chat to all the other attendees. And looking forward to see you in half an hour, where the first presentation in the next track will be, in the technology track, will be from Sebastian Grabler from Semantic Web Company, Semantic Metadata Management with Pool Party. And in the business applications track, the opening presentation will be by Ileana Zunov and Tolo Primo from Ontotext on linked live data inventory, followed by the much awaited presentation of Martin Romaker from Roche on fair data and knowledge graphs. Then a presentation by Vincent Cassidy from IET on unlocking the value of structured data in spec analytics. IET is one of the leading scientific publishers. And then this business application session will finish with presentation by Steny Solitude from our partner Perfect Memory. Enjoy the break. Take the time to visit the booths and talk to the other attendees. Try to make it more live than a typical virtual. I think there are plenty of people waiting and looking forward to talk to you. Thank you.
Okay, thank you. I'm looking forward to see you face to face soon, but for now, this is still not possible. Thank you.